Oh, here's 5 minutes of background on Gustav Kirchhoff, the German physicist, mathematician, and chemist who was born in 1824 in Königsberg, which back then was in Prussia. So obviously, Prussia doesn't exist nowadays as a country. It covered an area that now we'd think of as being part of Eastern Germany, a big chunk of Poland, bits of Lithuania. So heading from Germany east up towards the Baltic states. And Königsberg, which is now Kaliningrad. So there's the Kaliningrad Oblast, which is a little bit of Russia that isn't attached to the main bit of Russia, and it just sits there on the coast between Poland and Lithuania. And that's where Königsberg, as it was known, is. So Kirchhoff, he was born there to a Lutheran family of pretty good education and high standing. His father was a lawyer. He went to university in Königsberg. He then moved to Berlin before taking a professorship at a university in what was then called Breslau. So he's now in Poland, and this is where my lack of knowledge of Polish is going to catch me out. I think it's pronounced something like Wrocław. So it's written like this. But my Polish is non-existent. But I think it's something like Wrocław. Anyway, so he got a professorship there, but it was called Breslau back in the day. I mean, that was another town or city that was in Prussia, which is now in Poland. Of course, he's best known to physicists for his circuit laws. We're continually writing those out. They were pretty much guaranteed to come up in an exam question before we head off to university. He formulated those circuit laws in 1845. He was only 21 when he came up with those. He was still a student. Quite incredible, really. Later on in his career, he collaborated with Robert Bunsen, who most people don't realise that Bunsen was German as well. Because it sounds like quite a British or even American name or something like that. But Robert Bunsen, he was another German. They collaborated together at the University of Heidelberg, which is the oldest university in Germany. So we're moving over to sort of southwest Germany, something like that. And together, Bunsen and Kirchhoff, they invented the spectroscope. So this is the instrument that divides up light. So in their case, particularly starlights, it divides it up into a spectrum, and then you can identify certain elements. If you look at a stellar spectrum, you'll get this, some kind of continuum, and you'll have emission lines and you'll have absorption lines. And by looking at these and the wavelengths, so this is an intensity versus wavelength or frequency, same thing really. Along the x-axis, and by looking at the wavelengths of those emission lines and absorption lines, then you can start deciphering what the star or some other object, whatever it is you're looking at, you can start deciphering what it's made of, what elements are in that particular object. And it was Kirchhoff and Bunsen who first did this to identify what the sun is made of. So that was quite a breakthrough. They also, as a duo, discovered cesium, rubidium. This was in the 1860s. So a lot of work there in chemistry, and you can see where we've got this crossover here between chemistry and physics. Kirchhoff, he did a lot of work on thermodynamics. He studied the emission of black body radiation. So this is continuing on, same sort of theme as we've got here of looking at these emission lines and such like, and the thermodynamics there. And a lot of stars are well modelled by black bodies. So a black body, a term that Kirchhoff actually coined himself in the 1860s, and is then built into his law of thermal radiation. A black body, it's an object that absorbs everything, all radiation that falls upon it. So it's completely opaque, it's non-reflective, it's an idealized object. And then Kirchhoff and others were building up models of black body radiation. So how do these things radiate? because that's very close to then building up a spectrum of a star. When we look at these again, intensity graphs, so say intensity versus temperature, we come across these in our A-level physics, when we're looking at Wien's displacement law, and we see these variations where you get a peak, which is what that law's telling us, where the peak is going to be as a function of temperature. But this actual profile, this shape, which I think was pinned down by Max Planck, he really nailed the theory around about the end of the 19th century. So around about 1900, he was pinning that down. But it was people like Kirchhoff who were working out this, the initial laws of thermal radiation and how these black bodies emitted, these idealized objects, and how they emitted based on what their temperature was. So yeah, there's a lot of overlap there with the work that we do in the astrophysics section, and then Stefan Boltzmann laws and such like. So that the Stefan Boltzmann law gives us the intensity as a function of temperature. We've got the displacement law, which is just telling us where the peak is, and then Planck's contribution, which we don't actually cover before going off to university, but that's sort of bringing it all together into something more comprehensive. So Kirchhoff was pioneering that sort of work. So he was doing a lot more than just creating those circuit laws. I mean, most people would be happy just to come up with those. And he did that when he was a student, but he moved on to other really significant contributions around stellar spectra and such like. So there you go, Gustav Kirchhoff.